Okay, welcome back. Now, we're now going to talk about eliminating the parameter from the parametric equation. So we're going to go the other direction. So in many applications or many situations, it may be easier to graph a curve if we're just dealing with two variables instead of three. Okay. So in those situations, we may want to eliminate the parameters to make it easier to sketch the curve or to draw the curve. Now, if the direction is important, it's going to be necessary to involve the parametric equations in order to get the direction of the particle. Okay. Now, but if you're not necessarily needing the particle, then you can eliminate the parameter, and in some cases, it'll be easier to graph the function. Now, there are different methods of eliminating the parameter from the parametric equations. Not all the methods work in all situations, but what we're going to do is in the next few videos, I'm going to go over the most common methods that work. Okay, so that's what we're going to do. So we're going to start with polynomials. Okay, so let's say we have an example. We have x of t is equal to t squared plus 1. And we have y of t is equal to 2 plus t. And so let's say we want to eliminate the parametric, we want to eliminate the parameter, meaning we want to take both of this pair of parametric equations, and we want to reduce this to a single equation with just x and y. Okay, so how do we do that? Well, with polynomials, it's pretty straightforward. We can begin with the equation for y, and what we can do is we can solve it for t. Okay, so let's take, and in fact, for this case, I'm going to just eliminate the t for a minute. Okay, so I'm going to write this this way. So let's just drop the t for a second here. Okay, we know it's a function of t. So we have x equal to this and y equal to this. So what I'm going to do is I'm going to take my equation of y and I'm going to just solve for t. So if I solve this for t, I get t is equal to y minus 2. And so then what I'm going to do is I'm going to then substitute this in to x, right? I'm going to substitute it over here for t, for my x equation. So now what am I going to do? What am I going to get? I'm going to get what? Y minus 2 squared plus 1. So that's what I did. So I just took this and substituted for t in the first equation. So I'm eliminating the t variable. So what do I get? Now, what do I have? I have x equals y minus 2 squared plus 1. And so now I've got an equation that just has y and x in it. The t variable, the parameter, has been eliminated. So now all I have to do is I need to simplify this and solve for y. Okay. Now in this case here, I'm not going to be able to solve for y, and you'll see in a minute. Watch. So I'm going to just expand this out. I got x equals y squared minus 4y plus 4 plus 1. Right? So all I did was expand this out, and I got this piece here. Okay? And then I'm going to finally get x equals y squared minus 4y plus 5. Now in this case here, I'm not going to be able to solve for y because I'm going to end up with a plus or minus. So this is a function in y. So this would be x of y, right? And so well, you can probably see, since this is a quadratic here in terms of y, that this is going to be a sideways parabola, okay? And if you look at it that way, then it becomes easy to graph, okay? So it's just a, like I said, it's just a parabola in y, right? It's a quadratic equation of y. So instead of y being a function of x, we have x is a function of y. And since y is quadratic, that tells us it's going to have a form of a parabola, but it's in the horizontal direction. So this opens up to the left, opens up to the right, because the leading coefficient is 1, so it's open up to the right, and then you can graph it using what we know about parabolas. Okay? But the main thing is we wanted this function here. And so this is the result, and this is where we would stop, because that is what they asked for. Have a great day.